These are the answers to Unit 2 Multiple Choice Quiz B. Problem 5 was obviously the biggest issue. 21 people get that one wrong, and then after that, just about half as many had issues with 15, 11, and 6. As usual, read the question, try it again, and then unpause the video to see the solution. First one, let g be the function given by that statement. It's a limit statement. What is the instantaneous rate of change of g with respect to x at x equals pi over 3? So the key to this one is recognizing that this g of x function is the limit definition of a derivative. So g of x is the derivative of cosine x. Why is it cosine x? Because I can see that cosine x is the function here. So when they say, what's the instantaneous rate of change of g, now I need g prime. Well, if I need g prime, that means I need to take the derivative of this derivative, which means I need the second derivative of cosine. If y is cosine x, the first derivative is negative sine x, the second derivative is negative cosine x. So I need to evaluate negative cosine x at pi over 3. Draw your unit circle if you need to. I probably should have, but the cosine of pi over 3 is a 60-degree angle. That means that the x-coordinate is short, 1/2, negative 1/2. The answer is C. Next one, below is an attempt to derive the derivative of cosecant x using the product rule, where x is the domain of cosecant x. In which step, if any, does an error first appear? So you have to error check somebody else's work. This is kind of an unfortunate question because there is no mistake. Every single step is correct. Step 1, cosecant times sine is indeed 1 because cosecant is the reciprocal of sine. Step 2, they took the derivative of the left side and derivative of the right side. They didn't take the derivative yet. They just wrote it in derivative notation. The derivative of a constant is 0. Third step, they took the derivative using the product rule, but left derivative of cosecant as derivative of cosecant. Everything else is correct. And then the last step, you're going to solve for cosecant x by dividing both sides by sine x. I'll bring the cosecant x and cosine to the other side, which is where the negative comes from, and then divide by sine. And you get that statement there, which is correct, so there is no error. Next question, you're given a graph of f and a graph of g, and you're expected to find h prime, where h is defined as this fraction there. So what's happening here is they're basically testing you on the quotient rule. If you don't have this memorized, put it on your formula sheet and write it out about 10 times till you do get it memorized. But the quotient rule is ho d high minus high d ho over ho squared. In some cases, the quotient rule isn't necessary, but in this case, I think the only way of getting through this messy fraction is to use the quotient rule. So ho times the derivative of the top is just f prime minus high derivative of the bottom, which is right there, and then the bottom is squared. This isn't the best notation, but to save space, I got rid of all the x notations. So instead of writing f prime of x, I just wrote f prime. To substitute in for all these values, you need to look at the two graphs. F of 2 is 3, and f prime of 2 is 1/2, because the slope at 2 is 1/2. G of 2 is 4, and g prime of 2 is negative 2, because the slope of this line is negative 2. So when you replace all the f's and g's and f primes and g primes with their respective values, you get something that looks like 1 over 100, which is the correct answer. Then the last one, you're expected to take a limit of this fraction here. What's happening in this one is that there are two different variables here. The limit is with respect to h and letting h approach 0, but there's an e to the x in a couple spots. So what you've got to do is separate the x statements from the h statements. If you factor out e to the x and a 7, you're left with 1 minus e to the h, all divided by 4h. Since the 7 and the e to the x are not necessary for the limit statement, they can be moved out front, and now you're taking the limit of this statement here. Well, when you substitute in 0, you're going to get 0 on the top and 0 on the bottom. That's a candidate for LHOP. So using LHOP and taking derivatives, you need the limit now. Oh, there's a typo there. That should be an h, sorry. Take the limit as h approaches 0, and then when you substitute in, you get negative 1/4. Multiply that by the stuff that's on the outside, you get the correct answer of this. Let me see if I can fix that h. This here should be H, not 0. Okay, so that's everything. Hope you understood everything. Since you got all those, maybe you'd enjoy a picture of a adult female jumping spider. You're welcome.